Welcome. I'm Hunter Holtapel. At SLB, we provide limitless possibilities to improve your reservoir's performance, from evaluation to intervention to stimulation. In this video series, we take you around the world to highlight how customers are optimizing their results using SLB solutions. This case study comes from the United States, where Asher Partouche, formation testing product champion, shares how new stress testing workflows and technology enable a customer to make decisions in an actionable time frame. Asher, thank you for joining.
Well, Hunter, thanks. It's a pleasure to be here today to discuss with you about this project.
Can you tell us a little bit more about what the customer was facing here?
Well, Hunter, this particular customer is working on the geothermal project, where they wanted to understand better the geomechanical properties of the reservoir they were interested in. And in this particular case, they are trying to collect in situ stress from the reservoir, and they were not able to fracture some of the zones of interest. So they contacted us to review if we have any solution for them.
So what solution did SLB propose?
In this particular case, we developed a complete workflow that goes from the planning phase, where we first plan using the existing model data that's available from the mechanical earth model. We can plan the injection process and estimate what would be the required pressure to achieve, to break down the formation. And as we implement that, now we can select the right hardware to deliver the job. And as we do it in the job and we provide the fracture, we can immediately update our model to then plan the next station accordingly and rerun again the workflow. So we do that continuously along the well depth.
You mentioned that the breakdown pressure was too high for conventional technology. Can you elaborate on what technology was used instead?
The legacy technology that was used was not able to inject pressure high enough to break down the formation. So we proposed a new technology that we just developed or introduced, which is hydraulic frac 10K, which is able to inject pressure up to 10,000 psi within the injection interval, which is almost double what was legacy technology was able to do. And so as we did that, we're then able to fracture the formation and provide the customer with the required information.
That's impressive technology. What were the results then for the customer?
In this particular case, they were able to assess each of the zone of interest, including those high breakdown pressure ones, which then they can use the result to update the mechanical earth model and proceed with a geothermal plan for their project.
Wow, it sounds like you're pushing the boundaries of stress testing. What does this mean for the future?
So in stress testing, I've seen a major revival in the recent years. It's a technology or a process that exists, been existing for decades, but now with the advent of a lot of the carbon storage projects, geothermal projects, that all require very accurate understanding of the geomechanical behavior to optimize the injection profile and the value of the project. I think it will have even more impact, and that particular technology will be very impactful as we improve our carbon storage capability and in order to reach the net zero target that have been set.
Asher, thank you for joining me today.
Thank you, Hunter. It was a pleasure.
I hope you enjoyed today's discussion on how stress testing and in situ geomechanics profiling assisted in acquiring valuable information for the geothermal project. Stay tuned for more case studies from around the world, where we'll demonstrate how we work together with customers to improve their reservoir's performance.